we think about individual scientists these days, what we do, we read mostly, and we still read a lot of papers. We read also digital documents. It would be nice to visually and effectively annotate these documents. There are several softwares available these days, like papers, like you can use Mendeley, you can use a lot of different things. But still, there's a lot of fragmentation, and it's very hard to create semantic annotation. That means that mostly we are still using free text annotation, and at times this annotation process is from what we are doing in our regular activities. It would be nice if these scientists could not only create pieces of annotation, but also they keep them private or share with colleagues and for entire communities that are interested in a particular topic, so for the entire web if they wish. When I say share, it's not only sharing like passive sharing, they just put a data out there or annotation out there, but it would be nice if scientists could share those data, triggering other people that they know they have the same. So I think feeds or other mechanisms that could help other people finding those data once they are shared. It would be nice if, as we read a lot of documents, manual annotation and go read the documents and manually annotate the documents is one of the things we could probably do, but it would be nice to have algorithms that could do that for us. And maybe a mechanism for recording our feedback on those algorithms. So recording if what the algorithms recognize was right, wrong, and hopefully benefit from the work of other people in our community. We cannot all do the same work again and again. Another thing that we is being able to search the annotation right now. I have a lot of printed papers on my desk, and when I have to find things that is impossible, I started to use software like papers. I'm using Mendeley and other things, but at the end, when I want to search something, it's still really hard. My way of categorizing articles and creating tags changes in time and so on. So it would be nice to have something a little bit more structured semantically. And another thing we might want to do is once we have this annotation and we detected semantically what we are talking about, to be able to retrieve additional content from external sources. That can be simple like pictures or additional data about a particular entity, or new annotation that has been published recently on that entity, or journal articles, data available related to the entity, and so on. If we talk about communities, our group is expert in creating scientific communities. In scientific communities, usually have curators. There is an organization. So these scientific communities have like a process in which they annotate or they select, articles and they propose them to the scientists. They can be called, for instance, of the week or mechanisms like that. It would be nice if the scientific communities could annotate those prior publications or prior sending them to the crowd. It would be nice if they can see the annotation they create with their credentials. So a community like a Swan, for instance, that wants to maintain a high standard of quality, they might want to publish their own annotation that has been created by their curators with certain stuff. And they want to be able to track what happens annotation. They want to be able to market as theirs, and if somebody else wants to do it, we have to keep track this annotation they publish, they can trigger discussions in their community, and they can trigger other interesting things. For instance, they can, through the annotation, link internal content. Often scientific communities have databases, and they are in a section of their website. But it's hard to have a very good integration between the different parts, like the documents and the different databases. So the annotation would be possible to do that, or link to external resources. Everybody these days is like linking to PubMed or Ontology or Uniprot and resources like that. It would be nice if these ways of connecting the different things would be more uniform and standardized, so people can create mashups very fast and easy. They can also, scientific communities might want to simply overlay these annotation documents, simply showing this, but another option would be to use the annotations as part of the annotation process. So if wikis or we have other kind of documents that are evolving in time, we can use annotation to incorporate people's comments and feedback, for instance. Also, a scientific community that is working on a particular disease might be interested in connecting to other communities and share data with other communities that, for instance, have interest in terms of genes and proteins and pathways, and that's not very uncommon. Finally, we can think of text mining providers that, or people that are providing algorithms for entity recognition, that could, if we have a system that allows them to provide a standard way of displaying their results on top of the document, at that point they can collect user feedback easily, and they can collect the feedback from the communities. They can use that feedback to improve their services, or we can use that simply to improve the way we publish annotation. That doesn't really matter. This we have a mechanism for doing that. In general, what I'm trying to say is that it would be nice mechanisms for managing annotation that can be shared across different communities, connected or not. And if we have a standard way of doing that, or something that is close to a standard way of doing that, everybody would benefit from it, including other people that work, for instance, on ontologies. If a lot of people are annotating the same terms with the same text span in a document with different terms from different ontologies, there might be an analysis you can do there, and you might discover mappings in between ontologies or other kind of relationships. And also, you can do a lot of data mining on those annotation items that people create. Now, if we want to create such an environment, we need a few components. We need a model for sharing the annotation. Then we need at least one application for producing the annotation, but if we have a model that is shared, multiple applications can come up. You can imagine people can annotate documents, can annotate pictures, can annotate database records, can annotate files, somewhere like that. So there might be different applications for doing all these kinds of annotations. Then we need applications for searching and consuming the annotation. And if the model is shared, anybody can build a simple application for consuming annotation, for searching it, leveraging semantic definitions and so on. We might want external things like text mining services and external databases. And one of the examples is provided by the antibody registry that comes from NIF, that provides a list of antibodies with the vendors and with a lot of other useful information. Such a collection was not available before, and it's important when we annotate to be able to that the exact antibody that has been used for that process, for being able to reproduce that process. Other databases are PubMed, PyPortal, and so on. Our initial idea is we created a model that is called the Annotation Ontology. That model actually was born, like, I think in 2009 or something. It was model is developed in parallel with the application. There's one annotation tool that I will demo in a few minutes. There's one annotation tool to create some of the annotations I've been talking about until now. It's mostly document centered, so it doesn't allow users to annotate files yet or database records. But we don't exclude that in the future that will be possible. And this one annotation tool is connecting to a few external resources like PubMed, Bioportal, the antibody registry you said before, and soon we'll be able to import the entire Swan knowledge base for those that know what that is in the annotation tool. So when you create claims and hypotheses, we'll be able to connect them to an existing in the Swan knowledge base. The Ontology and this one tool are twin projects in the sense that they share the same goal. Probably the annotation is a bit more general because it allows you to annotate, as I said, a lot of different things. And right now, this one annotation tool is limited to documents. Even if we have a prototype also for annotating images that hopefully we will have time to integrate soon. So these two projects have a goal is semantic annotation of digital sources. Again, those can be documents like in this annotation tool or data that you might want to point to a particular record of a database. And they're fragments, and that's a very important point. We are not simply annotating entire documents or entire databases, but we want to be able to point inside those documents to a section of an image, to a record of a database, and say something about it. This project has been developed in parallel, and that's very helpful for me, especially because I can have a very short and close development cycle, and I can test the changes in one project against the other, and I can make sure that what has been defined in one makes sense for the other, and so on. And these two things, these two projects, one is an ontology and the other one is a web application, are part of a larger ecosystem that comprehendes this one hypothesis management tool that is known as Swan. A lot of ontologies and ontologies we are producing through the HCLS that is working group, the NIF antibody registry. The tool is integrating with, I'm working on that, it's not ready yet. We'll integrate soon with Saturn for a representation of the graphic objects, with the shock ontology for representation of users and communities. We are working with Elsevier to provide a UEMA connector in a way that everybody that uses the UEMA platform for text mining will be able to translate the results into annotation ontology items. Those items will be imported by this one annotation tool and will be displayed on the documents and so on. So I would like initially to spend a few words about the annotation ontology, just explain what that is and how it works very simply, and then I will jump to the demo that will be hopefully live. I will show the tool directly while using it. This one, the annotation ontology or AO, it's an open ontology that you can find on the web, and the link is there. It's a vocabulary for representing and sharing annotation of digital resources, and again, they're fragments. It's currently in use by several projects. And that's probably the reason why I'm talking here today. We are working with this for the integration with the UEMA text mining framework, and that's going to use the AO as lingua franca for exchanging annotations. It's used by the Utopia project for those who information on top of the PDF of the document. It's used by the filter push project. That is a project for biodiversity where they're interested in annotated images of plants, animals, and interactions between plants and animals and animals. And they're also interested in annotating databases with records at different level of granularities. Is also used by the Living Document Project, and that's for lab in Europe. These are some of the groups, so major pharma that is using the tool. AO has been designed with a few principles in mind, but it's important to remember three things. In AO, I want you to make sure you serve all the provenance. It's very important, and this is something that comes from our experience in developing Swan. It's very important that every assertion that people report, especially in science, comes with all the provenance attached to it, so we know exactly who said what and hopefully in what context. And that's very important for the trial. AO is designed with the orthogonality principle in mind. That means AO per se is not a very complex model. The idea is to relate to already existing ontologies, for instance, one for the scientific that are ontology like standard for entities or proteins and so on. This model can be simple, just list of terms, or more complex. It doesn't really matter. AO is simply providing you the link in between the digital resource and that space, that way of defining knowledge in that space. The other thing is AO is extensible. AO core is very tiny. I knew since the beginning that different groups have different needs, and this turned out to be very true because when I work, for instance, with the filter push people, they are interested in records, in specimens, and slides with materials and so on. They're different, very different requirements. So the idea is that you use AO as a core, and then you extend AO for what you need to do, and at least we can still understand that there are some sort of relationships in between digital objects and some pieces of knowledge. So what I said is basically depicted in this picture. AO is simply linking something that is a digital resource or its fragment with what is called in the picture a topic. As a matter of fact, the topic can be anything from free text. Sometimes it's not, because sometimes we just something in a document. That's already an annotation, but there's no real knowledge to it or semantic attached to it. Topic can be a term from an ontology, like a protein, a gene. Topic can be something more complex than that, a claim with relationships, or an hypothesis, or can be an experiment. So data that are attached to that resource or resource fragment. Documents can be of different format. We work mainly on HTML and hopefully very soon images. But again, other people are working already in databases, web services, and the fragments. Finally, again, the provenance is crucial. We want always to know who did what, and when I say provenance, I mean provenance of this finest grain level of granularity. Each relationship that is created through the tool that you're going to see purpose of AO, just to understand how AO works and how, unfortunately, the complexity can grow, and you need an application that is more visual to deal with it. For instance, I have a document. I want to say the document is related to data set related Swan. I'm talking about the whole document here. I'm not talking about a particular piece of the document or a document fragment. So in AO, what I would say is that I have an annotation instance that has a particular type, and for us, any type is qualified piece, simple annotation, that says this document, a topic, a protein coming from protein is one. And here on the top, you see the provenance. So you see who created that. This is me, this is my profile, and the data creation. Again, you can have something different. If you have motivation, if you have an expectation, and so on, those can be things that you can add to extend the core provenance model. And this is a very simple example, but usually when we read documents, we want to do something more complicated than that. For instance, in a document, we can identify a protein, in this case amyloid beta, and user number one identified that protein. And I call it curator for now. Now, that protein is connected to a piece of the document. So what we need to do in AO is we leverage a mechanism called selector. Selector is defined as an abstract class, and then we have subclasses of that that can be instantiated for the different needs. For instance, we have document selectors, and one in particular is this one, prefix postfix text selector, that allows you to specify where the exact match, while basically specifying that match. So with this big if you need different mechanisms, for instance, your document is very redundant, and this is not really happening a lot in biomedical sciences, but for instance, so what changes from here and what I showed simply that the annotation item has a context, and that I identify as a fragment of the document where I touch the protein. Now, and if I'm reading the document, I might want to attach, for instance, a claim. This sentence in the document is identifying a claim, and I might want to say, because that span of text was included a protein, that claim is connected to that protein somehow. Also, I have an author of the article. I want to specify that the claim is actually authored by the author of the article, and this other person created the claim, and the link in between the claim and the protein that has been created. The protein, as you remember, has been created by user one before previously. So again, this overall idea is to have a community doing annotation, so you can see other people annotation if they make it available to you, and you can use their annotation for your own purpose. For doing something like this, the model becomes a little bit more complex. So the select down here on the right is still identify the red rectangle, that basically the chunk of text that is related to the claim. I still have the provenance of 4, and the annotation instance is still an instance of the annotation. What's different here is that the topic becomes a little bit more complex, and I have a claim. So I'm going to create a claim that has an author that is the author of the article, because when I annotate that, I'm not actually creating that claim. I'm simply or if you think about the fact that the article you're reading as a bibliographic object, and that object can be connected to other objects because this article is citing in the references section, for instance, a lot of other articles, and then this claim that I just created can be connected with another claim in the knowledge base saying these are consistent, inconsistent, and so on. The new claim is derived from another article, and so on. So as you see, that the network, the knowledge network, can grow very easily and very fast. It becomes a little bit complicated to chart it. It's hard to define, to draw a chart of all the possible connections that you can build and so on. And it's very hard to do it manually if you don't have tools that are going to help you in doing that. So the idea of the Swan annotation tool is exactly that, to allow users to create networks like the one I was showing that are useful for scientists, and they are kind of complex to be created in different ways. And again, we experienced with the Swan project in the past that, for instance, creating claims and networks of claims, losing the connection back to the documents was a problem for some people, and we experienced problems of scalability, so we introduced concepts like canonical claims and stuff like that. We wanted to collect all that experience we accumulated in Swan and to create something more document-centric and something like easier to use, something more immediate. So when you read a document, you can do something with it and store that annotation you're creating, and hopefully later on leverage that annotation for doing other things like simply retrieving documents, or use that annotation and claims for creating new articles, or using them for writing a grant proposal, whatever your need is. And now I'm going to show you live the demo of the Swan annotation tool. Before that, I want to thank a bunch of people, just because I don't want to forget. Obviously, Tim Clark, that is the PI of the project. Marco, that is the person that helped me out in defining the first draft of this tool. The integration of the different pieces is not trivial, and in fact, with the Amazon cloud going down, that came out pretty strong. That is not trivial to integrate all the different pieces. I will work to simplify the probably. I want to thank Sudesna and Larry for the app with AO. They need people that help me out with testing of the tool and defining web services for connecting to the antibody repository, and Jonathan, that just started and provided me already very useful feedback. And then the Elsevier people, again, we are working for integrating UEMA, and Adam West and Amsterdam from a pharma. And I want to jump to the tool. The Swan annotation tool, that is here, it's basically the union of a server side that allows you to browse the annotation you created. Right now, allows you only to browse such annotation and to create an RDF model of it that you can share. And this application you see here, that is basically a real browser inside the browser that allows you to load documents, read the documents, and perform the actual annotation process. So this little browser that is written in GWT and translated into JavaScript has an address bar, as you can see. You can type there an address. That address you are typing there, the page actually corresponding to that address will be loaded in the tool through a proxy. That's something necessary because of the limitation of the same source. Because of the same source restriction in the browser, so we load everything to a proxy. That is sometimes can be a problem for when you have to access some content that is behind authentication. But we are figuring out to do that, and actually we are able to, for the people that are interested in the SMA collaboration, we are able to load with the tool and to authenticate into the document that Elsevier is providing for us. do is I'm going to load a page from PubMed Central. The tool is recognizing for now two different sources. One is PubMed and one is PubMed Central. You can load any other resource, but if you load from PubMed Central or PubMed, the tool will start doing something automatically for you. And what is the tool currently doing is trying to extract all the bibliographic objects. That means the bibliographic information, the list of the references. A PubMed Central document, the tool initially tries to see if there's an annotation available for that, doesn't find any, and as you can see, in the bibliographic object. So if I open the right part, part of the screen, I see a tab called bibliography where I have the bibliographic object for this article, the one that I opened, and all the list, and the list of the references here. Now, what you see here is basically what happened is that the tool looked at the HTML page coming from PubMed Central, extracted the PubMed IDs and other IDs that the tool found, and he basically asked PubMed to provide the metadata associated to those publications. And what you see here is a view, of those metadata. So you have links back to PubMed, and if you click here, you simply open the PubMed record for that article, and if you click this little pen here, you can actually open the annotation tool that loads automatically that PubMed page. So you can annotate directly the PubMed record, and automatically the tool, like PubMed Central and PubMed, are two of the resources we recognize, so automatically we have the bibliographic object for that PubMed record. The bibliographic objects are very important because if you a network of communities that exchange annotation, the bibliographic object is probably one of the few ways you have to make sure that the different communities understand what the source that has been annotated is. So it's very important to have the maximum number of IDs or information about the object you're annotating. Now, I have this list of bibliographic objects. This has been collected into a set. The tool is able to organize annotation in sets. I've created the concept of set just because it was clear since the beginning that you can annotate several things on a single document, and multiple people can annotate the document according to different perspectives. So the sets are collecting a list of annotation item. In this case, this set has been generated by the tool here. As I said before, everything is in the tool as problem. So every single piece of information you add, there's a problem attached to it. In this case, this set has 48 elements and has been created by the annotation tool with 7. Obviously, we have also the demonstration. The other thing that you might notice is that the set in this case is a topic. So all the items that are in that are graphic objects or bibliographic metadata according to the ontology. Have multiple labels, multiple semantic entities there to identify what the content of is, if you want. If you open again the bibliography here tab and you click on any of these icons, you're able to jump down exactly where the annotated item is. In this case, we have references. I can see anytime all the antibody. And again, with this interface, what you can do is, for instance, jump to the antibody registry, so you see the actual antibody registry. Also to the catalog of the vendor that is selling that antibody. So you can, if you know something about it within the article, you can figure out a little bit better if that's what you're interested in. And we say this, the ones with antibodies, obviously if you go in the antibody summary panel, you see the list the antibody will have been annotated in this specific article. As I'm running out of time, the last thing to show is how we can run text mining. I've been saying before, we are working on integration of UV. We can also develop anytime custom connectors to text mining services. In this case, I'm going to run text mining, the NCBO text mining service. What I'm going to do basically is I'm going to send the content of this document to the text mining service, and I will get back the results and I will display that page. You can imagine that right now I'm sending the whole page away, but in the future we might be able, for sources we recognize, for instance, Pubmed Center, we might be able to send only the important pieces of text that I want to analyze and not the full document like the menus and stuff like that that produces a lot of noise. Once the UEMA integration will be completed, everybody that is using services with UEMA will be able to basically run them, the results in our tool and curate them. I think that's the crucial and the very important aspect of this tool. Now, the results, as you can see, came back, and we have a list of terms that have been recognized on the page. Now, the idea is that you can, for instance, read the document and see what the NCBO annotator attached to the different sections of the document. For instance, to brain development, two terms have been recognized. Attached, like one is brain development and the other one is developmental process. So I can record my feedback and I can say the first right and become screen. And the second one is still right for me, but it's too broad. Probably I'm not interested in seeing that on the page. So I click here and I can also provide a motivation. Either the result is too broad or why it's wrong and so on, and I can apply this. And this is something we record with all the provenance. So if you imagine the same document analyzed by different people that give different feedbacks or multiple feedbacks, you can use those data to understand how good and accurate the text mining services are. You can use them to then do this process and the annotation to text mining services. They can improve their services or simply use them for improving their solutions. So once they do this process, I simply save my annotation with all the curation, and now the last thing I want to show you is that I can always see my annotations, so the list of annotations I create on the document. And the interesting part that is related to AO is that I can always serialize that annotation in RDF. And this is the RDF that represents the annotation that I just created, all those items coming back from the NCBO text mining service. And this is basically the annotation that we share with Utopia, and we plan to share with other people. And even we are talking about integrating the AO framework and so on. And in this RDF, there is everything that the tool knew. So not only the annotation items, but all the provenance, all the types, all the connections with the external resources and so on. So everything. The idea is that this RDF will be complete. So that. It is that the RDF would be the exchange mechanism. So when this is complete, I will be able to import the old annotation in the new version of the system, like with zero costs. And I think this is pretty much it. The other thing I want to say is that this to apply to biomedical things, proteins and genes, and we have antibodies. But as a matter of fact, one of the basic features of the tool is the qualifiers, and here you can really attach any term from any domain. And all these other things like antibodies or discers, these are plugins for the application. So I created plugins specifically for those topics, but we could potentially create a plugin for anything, like having a plugin for pathways or whatever we need in the future. Also, if other people are interested in other topics not really related to biomedical things, we could potentially develop other plugins for those aspects.
So Paolo, first of all, thank you very much. This is really a wonderful tool, and I want to give the chance right now for some other people to ask some questions. I have a couple of questions for you that I will ask if nobody else chimes in at this point. Anyone? Okay, so let me I guess start the question with. So I see your science news piece, and I've had some kind of bad experiences trying to annotate to science news pieces because they tend to go up and then they come down. But these annotations would presumably stay in some database somewhere on a cloud, presumably. So how do you deal with the fact that your data might be changing? I mean, PubMed Central obviously will not change, but some of these, other pieces of information will change. Do you store?
There are several things you need to do. First of all, the model, in our case, the annotation ontology, has to be able to deal with documents that change. Sometimes a document change for like in build parts. In that case, you have to be your mechanism for identifying the fragment has to be robust enough. Some other times the documents like in a wiki can change dramatically, so you lose the link of your annotation to that fragment. What we could do and what I've been thinking of doing is to have some sort of robots that periodically is going and checks if the annotation is falling off and or the content is still there and I can still link it. That's one thing we can do. The other thing that you might want to do, if it's possible, but this is very related to copyright issues, is to cache sometimes documents. This happened to me a lot of times in Wikipedia, where when you write a paper, you cite Wikipedia, and then you go there after weeks, and Wikipedia changed, and the things we were citing were not there anymore. So sometimes you can store and cache them, but unfortunately, most of the times you can't. So there is no way though that we can control that, in the sense if the document disappears and was protected by copyright, there is no way we can store it. And we can still store the annotation, but at that point you can use mostly the annotation for doing data mining and other things, more than showing the annotation back in context.
Mm-hmm.
But yeah, as you said, if you deal with mainly with journal publications and things like that, the problem is not existing. Right. Because we are trying to make the selectors robust enough that if something in the surrounding of the document is changing, like a banner or pieces of the layout changes, we still can put the annotation in place. And that's more or less the same mechanism that Utopia application uses for PDFs. So as you can see, we can use the same effect that is robust for addressing different formats as well as documents that might change slightly.
Yeah, the one nice thing that I remember seeing was that you were able to annotate on top of a PDF or on top of a HTML representation, and Utopia pulled up the other version of the paper, and both were the annotations went into the right place on the document, which I think is very, very nice, very impressive. So no matter which version of a document somebody is annotating on top of, it almost doesn't matter.
Right.
Which
For
of course
those
it shouldn't,
interested,
but
we are starting from the 1st of April the process for doing the opposite. So the Adobe application will be able to generate semantic annotation through our server. I'm not going to explain now how it will work, but it will be possible to create the annotation on the PDF and see it in the HTML as well.
that's great. That
We
is
are trying to,
fantastic.
like demolish this wall in between PDFs and HTML that is there since ever.
Yeah, that is very valuable work. Does anyone else have any other questions, or should I ask my second question? Nope. Okay. Well, actually, I see that it's now noon, so we have officially run out of time. I'll be happy to stay on and ask and you know get any other questions answered if Paolo you'll stay on as well. But I did want to thank everyone again for coming, and I wanted to thank Paolo for doing a wonderful job on this webinar. So thank you.
I can stay on if you have other questions.